Hi, I'm Stefan Eeskens. I'm an Azure specialist and a Microsoft MVP. I have a particular interest for artificial intelligence. I have been involved in several AI-related real-world projects in the past 3 years. Therefore, I want to share some lessons learned and of course some technical bits with the community. Please follow me on Twitter, as I'll keep sharing extra bits and I'll be announcing the upcoming of new episodes. This course is made of multiple episodes, and some of them might not be recorded yet by the time you watch the current episode. The course explains some fundamental AI concepts and will slowly increase in complexity with real-world examples and concrete business scenarios that could be relevant to your enterprise. You will learn how to create and consume Azure Cognitive Services, as well as how to educate more advanced services and specialize them to fit your specific needs. No technical prerequisite is necessary, as I will try to be as exhaustive as possible in my explanations. However, the course is primarily intended to developers, but part of it is accessible to non-developers as well. So far in this course we mostly focused on NLP-related APIs. It's now time to see how to use the power of vision-related services. We'll start with a glance of vision-related services, but the meat of this episode is to leverage the custom vision service in our day-to-day business. Remember, in the previous episodes we built a chatbot that deals with IT tickets within the enterprise. We saw how to train Lewis to understand phrases, patterns and incident numbers. Let's now see how we can automatically detect the target IT system out of snapshots captured by end users when reporting incidents. As I told you in the intro, I want to have a quick overview of some services, but instead of showing how to consume them as I did in my previous episode, I'd rather want to show you two concrete examples of existing applications that make use of those services behind the scenes. I will show you two different products: Microsoft Stream, that lets you envision what you can expect from the video indexer service, and your FaceBot, a Microsoft developed bot that makes use of other APIs such as the Face API. These services are ready to consume, so the mechanism involved in creating and consuming them are very similar to what I showed you in my previous episode. So I invite you to watch them if not done yet. If you navigate to bots.frameware.com and if you go to the bot directory, you will find a very funny bot called Your Face. When opening this guy, you'll be prompted to send a picture of a face, so I will send mine. The bot replies with a funny and sadly true answer about my ridiculous beard and my dog-like look, but although this answer is funny, it shows you the power behind this analysis, as my age, my sex, the fact that I have a beard, are all detected. I invite you to test this bot out with your own pictures to understand what you can expect from the face and emotion APIs, for instance. Let's now see another concrete example that will show you what you can expect from the video indexer API. For those who know the product, you can skip that part and fast forward the video. For the others, I'm gonna show you Microsoft Stream. For this demo, I have downloaded the channel 9 video, which I added to Microsoft Stream. When I start playing the video, I can see a transcript on the right hand side, as well as the involved people symbolized by their extracted face. From the people section, you can easily identify who speaks when, and you can play the video at the location where someone you're interested in is speaking. Custom Vision is still a preview service, so we may expect frequent changes. Take this into account when you watch this video, as some of the things I'll explain might change in the meantime. It is used to create custom image classifiers, in other words machine learning models that are able to classify your business-specific images. It comes with a specific dedicated portal, which I'll show you in a minute. It comes with two APIs, a training API and a predictive API. You can programmatically train the service as well as consuming it. I will also tackle that part later in this video. Let's see how we can use custom vision in the context of the enterprise. In this demo scenario, a user sends a screenshot to our chatbot. That chatbot forwards the picture to predictive API that returns the most probable tag associated to the picture. In the real world, we'd also send the user verbatim to a machine learning model that would also try to extract the incident category from text, and we could combine both information to create a ticket inside of the ticketing system. In this episode, I'm not going to cover the machine learning part, I will only focus on custom vision. When navigating to customvision.ai and logging in with your Microsoft account or your corporate identity, you end up on this landing page. From this page you can create new projects. I have already created a channel line project which I'm going to describe. When I open the project, I can see the tags on the left hand side and the training pictures in the middle. Remember our scenario. We want to be able to identify the target application that is symbolized by the screenshot a user is sending to our chatbot. So here my pictures are a mix of screenshots of Windows Explorer and Microsoft Access. That's why I have three tags, Microsoft Office being a more global tag. So now I'm going to add a new screenshot as part of my training data, and I'll take one of Windows Explorer. I'm saving it using Paint. I add it using the built-in Add Image UI. And I specify the Windows Explorer tag. Now I can train the model again since training data has changed. Each training execution produces a new iteration. You can access all the iterations in the iteration history and define the default one to be used whenever predictions are requested by a consumer. Hitting the Quick Test button, I can test my iteration's prediction capabilities right away by uploading a test picture. Here I took a Windows Explorer screenshot, and sure enough the iteration tagged it correctly, although the exact same screenshot was not part of the training data. This shows the power of the service, because although my sample set of screenshots is rather limited, it already manages to find a correspondence with a high level of certainty. Similarly to Lewis, Custom Vision comes with an active learning feature. When clicking on predictions that were performed by a given iteration, you can adjust the system understanding by re-tagging predicted images yourself should the system be wrong. In this case, I see that one of my Access screenshots was interpreted as Windows Explorer. So I can open it, specify the right tag, save my changes and retrain the model. Last but not least, the settings screen reveals some important information. On the right hand side you can find the subscription keys. I will show you later how to make use of them using the APIs. In the usage section you can see the project boundaries, meaning 1000 pictures, 50 tags and 20 iterations. You can delete unused iterations should you reach the threshold. Also remember that this service is still in preview, so we can expect these boundaries to become higher with an associated pricing plan in the future. Now that we set up a minimal model, we can consume it from the chatbot. So I'm in the skin of an end user and I just encountered a problem when trying to delete a file. I want to report this as an incident because I don't understand what's going on. So I took the following screenshot that illustrates the problem. Now I'm gonna go to the company bot that allows me to report incidents, and I send my screenshot. Sure enough, the bot recognizes that this is a Windows Explorer related issue. Now let's try to cheat and send a picture of my face to see what the bot answers. Well, the bot doesn't seem to find a tag which makes sense, since I haven't educated my custom vision project with such pictures. Okay, now that we've seen some concrete use cases, let's see how to make use of these APIs in code. Before showing you the bot's code, I'll first show you a console program where I do both training and predictions. Note that there is a full GitHub repository available with more exhaustive code, but here I'm going to give you a high-level overview of how it works from a code perspective. So let's see our console program, but first I'm back to the portal just to show you that I currently have 8 iterations. If I switch to my console program and I run it, the first thing it will do is to add an extra training image and tag it with Windows Explorer. And then it will explicitly request the training. Now that the training is completed, let's come back to the portal and notice that we have indeed 9 iterations. I'm going to execute the second part. It's going to predict the tag of another test image using the prediction API. I probably hit a key accidentally, as it should have stopped to show me the result. Let me comment out these lines of code and run it a second time. Sure enough, it found the tag for my test picture. Okay, let's now analyze the code here. I have a project identifier that I have hard-coded here that corresponds to my Channel9 project. In the training method, I make use of training credentials using the training key available in the settings page of the portal. I then instantiate a new training API object and I add the training image, then I request the training. The other hard-coded value corresponds to the Windows Explorer tag. So here, for sake of simplicity, are hard-coded values, but of course you should make them configurable or even discover them using the APIs. In the test picture method, I also start by initiating a training object in order to retrieve the identifier of the last completed iteration. Note that the alternative is to skip this parameter, as it is optional, but in that case you need to make sure that an iteration was marked as default, else the API will throw an error. Then I simply create a prediction object with my prediction key and I send my picture stream to the prediction API. I then show the first tag found, which is always the highest probability. Here I'm not testing the level of confidence, as it's just a demo, but I'll show you in a minute how to do that in the bots code. Of course, I had to add some NuGet packages to use both the training and prediction APIs. Last but not least, you must make sure that your project is running at least in .NET 4.6.1, since this is the minimum level required by the NuGet packages. Back to our chatbot now. As for my console program, I have added the two NuGet packages and I made sure my project was running at least in .NET 4.6.1. In the bots message endpoint, I test whether the message contains an attachment or not, and if it does, I get the file stream and I send it to a helper method that will forward the stream to the prediction API, in order to detect to which target IT system this image refers to. Let's have a look at that method. So, exactly as we did in the console program, I'm using the prediction key to instantiate a prediction object. I'm passing the project ID, the stream and the default iteration ID to the predict image method. And I retrieve the first prediction and its probability. For the time being, when there is a 100% match, the value returned by the service is 1. If it's above 1, it means that you have another percentage, hence the reason why I divide the retrieved number by 100 to get the actual percentage. Then I simply test whether the prediction is above a certain threshold, which is in this case 0.5. And I return the tag accordingly. Of course, here again this code isn't production ready, as you should make these hard-coded values configurable and add some error handling plumbing. So we've seen how easy it is to train the custom vision service. We also saw that it comes with an active learning feature that is very similar to the one of Lewis, so it makes it easy to tune the model to your specific needs. Thanks to the NuGet packages made available by Microsoft, custom vision is very easy to consume. As always, data is key. In our example pertaining to incident management, the hardest part would probably be to collect all the screenshots sent over the past year and annotate them in order to upload them into the project. That would be for sure the most boring and tedious part of the job. However, the outcome you could get from that is really worthwhile. In the next episode, I'll be talking about speech-related services and I'll focus mostly on the custom speech service. Thanks for watching and don't hesitate to follow me on Twitter.